Hey guys, welcome to today's video. We're going to talk about the same tree problem from Leetcode. So given the roots of two binary trees P and Q, we need to write a function to check if they are the same or not. And what that means is, two binary trees are considered the same if they are structurally identical and the nodes have the same value. So this part is pretty simple, because let's say we have a node P with the value of 1 and a node Q with the value of 1 as well. Yes, they have the same values, so that meets one condition for them to become the same nodes, but let's see if they are structurally identical as well, which means they must have the same left subtrees and they must have the same right subtrees. So let's look at the left subtree of the node 1. It contains the node 2, right? Similarly, the left subtree of 1 here contains the node 2, and it's the same thing for the right subtrees, which is why they are the same trees. Moving on to the second example, let's say this is node P, this is node Q. Yes, they have the same values, but do they have the same structure? No, because node P has a left subtree, whereas node Q does not. Similarly, node Q has a right subtree, whereas node P does not. Alright, moving on to another example. Yes, these two trees both have a left child and a right child, but the left child of the node P has the value of 2, whereas the left child of the node 1 has the value 1. Alright, so they are not the same trees. So let's try to break the problem down. What does it mean for two tree nodes to be the same? So basically what it means is they must, let's say for two root nodes, okay? They must have the same values, and they must, let's say their left subtrees must be equal, and their right subtrees must be equal as well. So looking at these two statements, do you think we can use any particular technique to solve this problem? And the answer is yes. Alright, the name of the method is same tree. Basically, we computed something from the two nodes, and now we're delegating the job of further comparison using recursive methods, alright? Recursive calls. So, how that manifests is in this way. Basically, I want to check whether P and Q have the same values. If they don't, I can immediately say, no, they are not the same trees, right? If the root nodes themselves do not have the same values, they're not the same trees. Now we move on to the more interesting part, which is, okay, their left subtrees must be equal. So I'm just going to delegate this computation to a recursive call, alright? So it's self.isSameTree. Are the left subtrees of P and Q the same? If yes, are the right subtrees of P and Q the same as well, right? Because we want both their left subtrees and their right subtrees to be equal. If this condition is true, looking at it from the vantage point of the root node, yes, they are the same trees, because both P and Q have the same values at the root node, and both P and Q have the same left and the right subtrees. Alright, so that's why they are the same trees. So this code by itself is not sufficient to solve this problem, and the reason behind it is when we are calling the recursive function, we also need to consider what if P reaches none before Q, right? Or what if Q reaches none before P? What if P and Q reach none at the same time? Alright, and what reaching none means is, let's say P is a node with the value of 1 and Q is a node with the value of 1 and 2. So okay, for the first comparison, yes, they have the same values, right? They have 1, but when we call this recursive function right here, the left subtree of P is none. It reached none, right? Because it's non-existent, whereas the left subtree of Q is 2. right, is the node containing the value 2, which means obviously they are not the same trees because Q has an extra node. So if P does reach none before Q, which means if not P and Q. If Q exists but not P, right? So to rephrase this, if Q and not P, I would return false. They're not the same trees. So the same logic applies here. If P exists but Q reaches none first, we will return false again because P still has something but Q doesn't. What if P and Q reach none at the same time? If not P and not Q. Alright guys, what do you think should be the Boolean value here? Both of them reach none at the same time. So think about it this way. P is non-existent and Q is non-existent. Or another way is P is 1, 2, 3 and Q is also 1, 2, 3, and let's say their third nodes are equal. We've already found that out. What's the next step? So the next step would be to compare the left subtrees and the right subtrees of the third node. And the third node, their left and right subtrees are basically none, right? And because of this, their values match, which means the two trees are equal. Alright, so that's it for this problem. You might be wondering why I'm not checking this condition if P and Q, but I am implicitly checking that condition right here because implying that, so P and Q existing implies that I can access their value properties, right? If either P or Q were non-existent, I could not do non.val, right? So in order to access the val property, this must be an existent node, right? Alright, so let me remove these comments. And let's see. Let's run the code. Yep, that works. And if you want, you can try your own custom test cases as well. Here, Q reaches none faster than P, so it has to return false. And it does. So let's submit it and see what the result is. So it passes the test case. So if you guys have any questions about this problem, I'm happy to answer it in the comment section. Please let me know. Otherwise, guys, I'll see you in the next video. Thank you.